your booklet. I believe this is it 101? Solving logarithmic functions. We'll have one more thing, and that will be that. The top three on your front page say review, solve. These are things that we did yesterday, so let's just go back through them. We're going to solve these equations. Now, what kind of equations are these? Let's snap. Don't start with me today.
Logarithmic.
These are not logarithmic. I don't see the word log in them. Why are these exponentials? Because the variable is where? In the dang exponent. Now, let's look at A. How would we solve equation A? 5 to the 2x squared equals 5 to the 50. Why do we set 2x squared equal to 50? Because they have the same base. So by golly, 2x squared. While you're solving that, I'm going to get something and clean this, and we'll see if that helps. Solve that. Please don't start with me today. So how did you solve it? What'd you do? Divide by 2, and you end up with x squared equals 25. So x equals, be careful. You are taking the square root of 25. What's the square root of 25? Plus or minus 5. Plus or minus 5. Now, here's the deal. You're going to check them. We're going to make sure they both work. Since we got 2, we're going to make sure. If x is 5, 2x squared. What's 5 squared? 25 times 2? 50. Got it. If x is negative 5, what's negative 5 squared? 25 times 2? 50. So both of these work. Look at B. Common base of 3. Good. 9 is 3 to what power? 2. So that's 3 squared raised to the x plus 2. Okay, I'm done. I'm going to just go to a blank, and I'll just get my... All right. So 9 to the... We'll just put this on here. 9 to the x plus 2. And here we go. 27 is 3 to what power? So this is 3 cubed to the negative x. So when you raise a power to a power, what do you do to the powers? You multiply. So what are you going to... If I have to, I will. If I have to, I'll go right over there. Well, yeah. If I can't record, I can't record if I go somewhere else. So we're going to pray a little bit. Okay. 3 to the what? Come on.
3
to the 2x plus 4 equals 3 to the negative 3x. So what do I know? Bases are the same. So exponents have to be the same as well. Solve it. How do you solve that? How do you solve it? Go. Subtract. Well, I could. No, I can't subtract 3x.
Then you would subtract 4 to be a negative. It would be negative x plus 4 equals 0. Plus, then you subtract 4 being negative x.
Where are you getting a negative x?
And you subtract, or no, you'd add 3x, 5x.
Right.
5x equals 3. Negative 5x.
You can do this 2 ways. Do you notice you've got x's on both sides? Do you have constants on both sides? No. So since the constant's there already,
You subtract 2x.
I'll just subtract 2x. Now you can do what you said. It's fine. It just takes an extra step.
You get 4
Equals. So what's x? Right, you divide by negative 5, so it's 4 over negative 5. Then I think there's one more in that review part. I promise I'll help you. I promise.
So you want to change that to negative 4?
Well, what's a common base that I can use? With 4 and 2, I can use 2, so let's change them both to a base of 2. So, okay, so what about a negative 2? So, Jocelyn says 1/4 is 2 to the negative 2. Is she right? Yes, because remember the negative means it's 1 over 2 squared is 4, so that's 1/4. So that's 2 to the negative 2 raised to the 2x. How would you make 1/2 2 to a power? That's the hardest part. What are you going to do now? 2 to the equals 2 to the... Now, this problem screwed you up yesterday, or a problem similar to this. What's true? Bases are the same, so exponents have to be the same. Good. So negative 4x equals negative x. Fine. If I add x to both sides, negative 3x equals what? 0. 0. Divide by negative 3. What's 0 divided by negative 3? 0. Okay. Are you in a good place? Okay. Listen. There are rules for solving an exponential, or excuse me, a logarithmic function. I'm not going to go through those except to look at the last one. Do you see the last one, that number 3 says check for an extraneous solution? Now, it's not bad, I promise. Now, no, I want you to see what it says in parentheses. You cannot take the log of a negative number.
So it just can't be negative.
Right. I want you to look at why that's true. If I do log base 4, no, let's do a simple one. Log base 2 of negative 4. Now remember, that's asking you 2 to what power is negative 4?
Nothing. Because it would go to a negative. It would have to have been a fraction instead of a negative 4. Because you can't multiply it by a negative or put it to a negative 4.
Right. If I put a positive number like 2 or 3 or 5 in here, is that going to work? 2 squared is 4. Well, what if I put negative 2? What's 2 to the negative 2? That's 1/4. Well, what's 2 to the 1/2? Square root of 2. If I take a positive number and raise it to any power in the world, you're going to get another positive number. You can never get a negative number, and you can't get 0 either. This is impossible. You cannot do this. So you always have to check and make sure, does that answer make me have to take the log of a negative number? And if it does, you go, throw it out. Bless you. All right. Let's look at A. Log base 4 of x equals 2. Now look at the first step in the box. What's it say? Rewrite as an exponential. Rewrite. How would you rewrite that as an exponential? 4 to the second equals x. Oh, 4 to the second equals x. So what's x? 16. That's it. That's it. Now, So if I make that 16, am I taking the log of a negative number? No, I'm taking the log of 16. That's good.
There's going to be a catch here like that.
Oh, ye of little faith. Log base 3. Well, it's not going to be like that all the time. I'm not going to lie to you. Oh, look at B. See? Let's rewrite it as an exponential. 3 to the third power equals this. 3 to the third power equals this. Answer. What you got? Yep. Did I take a square root? No. The only time you're going to have positive negatives is if you're taking a square root. Solve it. What are you going to do?
I don't like that. That's not fun.
What's 3 cubed? So 27. Look, this is algebra 1. And you passed algebra 1. Yes, you did. You passed. Don't mess with me. You know how to do this. Yeah. You know how to do this.
Yeah, but it doesn't mean it's not hurtful.
Doesn't mean it's not hurtful?
Wait, so do you take, okay, yeah, that's what I thought, and then you divide by 2, so it's
Yeah. All right, now. We haven't known each other very long. Okay, but we're going to check it. If x is 12, what's 2 times 12?
It's all positive.
Plus 3. Is 3 cubed equal to 27? Next. Inside the booklet. Here we go. Here we go. All right. Log of 2x plus. Now.
Oh, wait, no. Just the 2 because you're going to multiply those together, and that's equal to. You both right now.
Ah, how many times do you see the word log? Twice. And what operations between them? A plus. How can you rewrite that as 1 log with no plus?
Add them together.
Oh, a plus you condense by
Multiply.
multiplying. Remember? You condense a plus by multiplying. So this is. So hang on. I'm going to write it like this, okay? It's 2x times 5x plus 15. Now, if you don't have to do that step, that's fine. I'm not going to complain. All we're going to do is we're going to multiply this times this. And notice, how many times do I see the word log? 1. This is log of. What's this?
Plus 3.
Now, stop right there. Hang on. Now, have you done anything right here that you did not know how to do? No. Now I'm going to cry a little bit. And since we've got this written as 1 log, I can write it as an exponential. What's my base? 10. 10 to the second power equals this. Oh, I got a little equation I can solve. What's 10 squared? By golly. Where did my problem go? Your base is 10. 10 squared. What is 10 squared? You said it was 100. Oh, guess what's getting ready to come into play? Factoring.
No. Why is there so much?
The reason why I don't touch my
Factoring. Got people absent. I got to. Now, I know. Okay. Do you notice you got an x squared? Then you got an x. You got a constant. We're going to set this puppy equal to 0.
Oh, no, I know what this is now. This is like last semester where you get like the order of the highest power.
Equals 10x squared.
Yeah.
Minus x squared.
Yeah.
I loved factor. I loved factor. What's the first thing you look for when you factor? Oh, greatest common factor. There's a 10. Okay. There's a 10.
I wrote you big first.
10 times. Go.
Squared.
X squared plus 3x minus 10.
That better be it.
Now, come on. Here we go. Here we go. 10 times. X and X. What are your signs? Excuse me. What are your signs? Plus and a minus. Good. 5 and what? 5 and 2. 5 and 2.
I forgot that.
All right. So X would equal -5. Oh, shut up. So X will equal 2.
That's so much. My hands gonna I don't understand. I'm running out of brain capacity.
It says check for extremes.
Well, listen, we're going to check them. Yeah. Now,
It says check for extremes.
there you go. So now what we got to do,
You said this was easy.
you tell me what's hard about what we did. Nothing.
The fact that my hand's gonna cramp.
Poor
I
baby.
don't write that much when I write papers for English, and Miss Gill is insane about how long her papers are.
-5 and 2. -5 and 2. Shush, I don't want to hear it. -5 and 2 were the answers we got. If we let X equal -5, what's 2 times -5? I would be taking the log of a negative number. That's not okay. You got to check
All
it.
of that for it to not work? Are you serious? Oh my goodness. Wow.
If X is 2, 2 times 2 is 4. I can take the log of a positive number. 5 times 2 plus 15, is that positive or negative? Positive. I can take the log of a positive number. Your answer is X equal 2. Was that sarcasm? Where did it go? Oh, jeez Louise. Dang it.
Oh, dude, I'm gonna fail every class.
Listen, we're going to, no. D. Log of 5. Okay. For those of you who are not here, I'm sorry. I cannot function with this smartboard right now because it will not cooperate. I'm going to have to go offline, so the video's just going to be what you got. Come see me.